We just went over what sine and cosine graphs look like, so now let's take a look at how those graphs can be transformed. What changes can we make to those graphs to make them taller, skinnier, shifted to the right, left, up or down, that type of thing. So this is the idea behind transformations. So the main formulas we have to remember for transformations is the one for sine graph, so a sine b x minus c plus d, and then cosine, okay, cosine is y equals a cosine b x minus c plus d. So these are exactly the same thing. We just replace sine and cosine. Okay, so a is the vertical stretch. And I'm going to try and write this here. Actually, I'll write it below because it's the same for both of them. So a is the vertical stretch. Vertical stretch. So if a is less than 1, let's say this was sine of x. If a was less than 1, then that would mean that the graph is shorter. The graph is shorter. So it didn't change phase. Whoops. The graph would be, yes, so let's see here. I'm going to draw it more accurately. So if this was sine of x, if a was less than 1, it would look something like this. Right? Something like that. I'm not drawing it super well here, but that's kind of the idea. If a was more than 1, that means that it would be higher. As I kind of mentioned in the last video, it would be expanded. So the phase isn't changing, except the height at each point is. And it kind of gives you this beautiful shape, right? When you change the a values, but the phase is the same. So the a value is the vertical stretch. I'll write below here b. B is that determines the period of the graph, and we'll talk about what that is after. But there's no like immediate way to figure out what the b value is. What determines period, and we'll be able to look at how to determine that in the examples below. Now the c right here, that's called the phase shift. Okay, so the phase shift, right, I talked about it in the last video with sine and cosine. So let's say this was our graph here of sine. Oh, it's not straightening out for me here. If this was our graph of sine, right, and we know that cosine is shifted pi over 2 radians to the left, right, in this case, c would equal pi over 2, because c is just how much the graph is shifted to the right or to the left. So if it's shifted to the right, like cosine is, or sorry, like sine is compared to sine, right, that would mean that our c value for sine would be pi over 2 if our cosine shift was 0. And I know it's just kind of random words I'm spitting out, but we'll see like exactly what this means in the examples. Okay, so A is the vertical stretch, B determines the period, C is the phase shift, and D is called the vertical translation. So this is probably the easiest transformation to find, because if we had, say, a sine graph like this, sine and cosine, their midpoints, it's called, the point that kind of runs along the middle of the graph, is at 0. So the average value for sine across an interval is 0, because if you draw a line straight in the middle, right, it's always going to be along the x-axis when y is 0, right? But if the graph is shifted up, say like this, say we have, actually I'll draw a new one. Say we have a graph like this, where the midline is here at 1, well then D is going to be positive 1 because it's shifted 1 unit up. So for every y value we had before, we're going to be shifting it up by 1. Now, if the midline is, say, -3, that means that it's going to be down here somewhere. So if we drew a line straight through the middle, then the midline would be at -3. So we can determine D like that. That's an easy way to determine it. Okay, so now that we know what all these things are, let's take a look at these questions down here. Write an equation in terms of sine and cosine for the following graph. So they want sine and cosine, right? They were very clear. So this question is trying to get you to understand that sine and cosine are the same thing, except they're just a phase shift different, okay? So the A, B, and D values are all the same, but the C value, the phase shift, is going to be different. Okay, so let's determine what A, B, and D are. C is going to be different, but what's A, B, and D? Well, our A, actually, let's do our D first. So D, remember, it's the midline. So if we were to find the midline of this thing, we draw a line straight through the middle, and we'll notice that it's right along 0. So its maximum is at +1, its minimum is at -1. Right in between that is going to be 0. So we can find it one of those two ways. So if D is 0, we don't have to worry about adding or subtracting anything at the end. Okay, so right here, D equals 0. What's A going to be then if we know D is 0? Well, our maximum goes from 0 to 1, and our minimum goes from 0 to -1. So that must mean that our amplitude is 1, because it doesn't go up or down more or less than 1. So A is going to be equal to 1. Okay, now let's do B. What's our B value? Well, the B value is going to be equal to what the period usually is. Okay, so 2 pi, that's typically the period of a sine or cosine graph, divided by what the period actually is. Okay, so the period of a sine or cosine graph is just from one peak to another, or one midpoint to the second next one, or the one trough, one lowest point, one minimum to the next. So let's do the peaks. Let's do from this peak to this peak. What's that distance there? Well, this is 0.5, and this is 2.5. So that must mean that the period is 2, right? Because the period is 2, because 0.5 to 2.5, that length is 2 units. So for one whole cycle to happen, that means that the period must be 2. So 2 pi over 2, the 2's cancel, we just get pi. So B equals pi. Now let's start to set up these equations. So we know A, B, and D. Now we just need to know C. So let's do our sine one first. So let's do y equals A sine bx minus c plus d. We know A is 1. So there's no point in writing 1 sine. We're just going to write sine. We know B is pi, so we're going to write sine of pi x minus c, whatever that is, and plus d, we don't need anything there. Okay, so because d is 0, so sine, remember, sine starts at 0 and goes up, comes down, goes up. So since this graph starts at 0 and it goes up in the positive direction, that means that we're not shifted at all. So maybe if the sine was like this, it started here, right? The sine graph would be shifted over 0.5 units, so it would be x minus 0.5. But this one starts at 0, goes up, it looks just like a regular sine graph. So we're not going to put anything in there. We don't need to put pi times x minus 0. We can just put pi x. So this is the graph y equals sine pi x. Okay, now let's look at cosine. So we know A is going to be the same, so it's going to be sine. B is going to be the same, pi of x plus or minus something. And then we need plus 0 at the end, but we don't need to write that, okay? So what's the phase shift of this? Well, cosine, remember, typically starts at 1 when x is 0, and it goes down like this. So how far to the right is our graph shifted? How far to the right is our green graph shifted compared to the left? Our black one, right? The original cosine. So notice how this distance right here is 0.5. So that means that our graph is shifted 0.5 units to the right. if we're thinking of it in terms of cosine. Okay, so that must mean that it's going to be x minus 0.5. So if it's shifted to the right, we're going to be subtracting, and if we're shifted to the left, we're going to be adding. Okay, that's another important feature of transformations. Okay, so these are our two equations, and this is not, that's my bad, this is not sine, this is cosine. So notice how sine pi x, cosine of pi x minus 0.5, those are the exact same thing, except the phase shifts are different, right? So the a value is the same, the b value is the same, the d value is the same, but the c value, the phase shift, is different. Okay, what's the cosine equation of this graph verified with two coordinates? So right now we're only focused on y equals a cosine b x minus c plus d. Right, so our a value will, let's actually first find our d value, because that's always the easiest in my opinion. So see, our maximum here is 2, and our minimum here is 0. And that must mean right in between that's going to be 1. Okay, so you can always find the d value, the midpoint, by doing max value plus min value over 2. So notice that the max value is 2, we're adding 0, which is the minimum, and we're dividing it by 2. So this is 2 over 2, which is just 1. So our d value is going to be 1. Okay, our d value is 1. So I'm going to write that above. D equals 1. Now let's find a. Well, if our d value is 1, right, if our midpoint's right in the middle at 1 here, to get from 1 to 2, we have to go up 1, and to get from 1 to 0, we have to go down 1. Okay, so the magnitude of the a value is going to be 1, but if we're trying to find cosine, is that going to be positive or negative 1? Well, cosine typically starts at its maximum and then goes down like this. So see how this is shifted a little to the left here. So I'm going to call it a positive 1, right? Because negative cosine would mean that it would have to start at its minimum and go up, and that doesn't really look like our graph here. So this point here is closest to the y-axis, so we're going to use positive 1. Okay, I'm just going to clean this up here. Okay. So d is positive 1, a is positive 1. What is b? Well, b is determined by our period. Okay, so what's our period? Our period is from one peak to another, the distance. So if this is negative pi over 8, this is 7 pi over 8. To find the difference between them, we do 7 pi over 8 minus this value here, so minus negative pi over 8. Now notice that these turn into pluses because we're subtracting a negative. So this would be 8 pi over 8, and the period, the 8's will cancel, is just going to be pi. So remember, our b value is 2 pi over our actual period pi. Pi's cancel, and we'll just get 2. So that means that our b value is going to be 2. So b is going to be 2. So let's start filling this in. Y equals a is 1, so we'll leave that. We're just going to go cosine of 2, which is our b, x minus c plus d. And d is going to be 1, right? Okay. Now let's find our c, how far shifted we are to the left or the right. Well, like I said before, we're typically right here, starting at our maximum, except now the maximum starts at negative pi over 8, this coordinate here. Okay, so this must mean that our c value is positive pi over 8. So y is going to be cosine 2 times x plus pi over 8 plus 1. Right, because if we're going to the left now, if our maximum's at negative pi over 8, that means that if it's x minus c, this is like x minus negative pi over 8. This becomes a positive. So if it's shifting to the left, it's always plus inside. So this is your equation here. And if we wanted to verify, like the question's asking, all we would do is we would take in some random point, like say 3 pi over 8, we would plug that in for x and see if we got 0, which was the matching kind of coordinate there. So so if we put in 3 pi over 8, this would be 2 times 3 pi over 8 plus pi over 8 plus 1. Okay, so this would be y equals 3 pi over 8 plus pi over 8. That's 4 pi over 8, right? Because they're both over 8. So the cosine of 2 times 4 pi over 8. Now 4 pi over 8, if we divide 4 and 8, we're just going to get a half. So we're going to get pi over 2, okay, plus 1. Now, the cosine 2 times pi over 2, 2 times pi over 2 is just pi, because these 2's are going to cancel, so the cosine of pi plus 1. Now remember, the cosine of pi was negative 1, so it's going to be negative 1 plus 1, which is 0. So when x is 3 pi over 8, yes, y is indeed 0. So we verified it with 1 point, with 1 coordinate. Now let's do it with 1 more, because that's what the question's asking. Okay, so we did it with 1 coordinate. Let's do it with 1 more. Let's do it with an easy one. Say, let's just do 7 pi over 8, see if we're right. So if 7 pi over 8 is our x, we should get 2 for our y, right? Because that's what that coordinate says right there. So y equals cosine 2, 7 pi over 8 plus pi over 8 plus 1. Okay, so 7 pi over 8 plus pi over 8 is 8 pi over 8. 8 over 8 is 1, so that's just going to be cosine of 2 times pi plus 1. So this is the cosine of 2 pi plus 1. Cosine of 2 pi, remember, is 1. So the cosine of 2 pi is 1. 1 plus 1. That does, in fact, equal 2. So we just verified with 2 coordinates that our equation was correct. Okay, find an equation for this graph. Okay, so, doesn't look like we're having any nice points here. We know that the maximum is 6. Okay, that's something. That could be useful. So this maximum 6. And we know that the minimum's at negative 2. So if we know the maximum and the minimum value, we can always find the d value. So the d is going to be the max plus the min over 2. So the average value between them. The maximum is 6 plus the minimum, which is negative 2 over 2, right? Well, that's going to be 4 over 2, which is 2. So the d value is going to be equal to 2. And once we know the d value, it's going to be easy to find the a value. Okay, so if we're trying to find an equation, this closely resembles, I'd say it closely resembles positive cosine, because positive cosine starts at its maximum and goes down, comes up like that. So we know that this graph's going to be shifted a little bit to the left. It's going to be shifted, let's see, if we go straight down from its maximum, that's going to be negative 1 units. So we know our phase shift, our c value, is going to be negative 1. Okay, now let's do a. Okay, let's do a. If we know that our d is positive 2 and we're using positive cosine for our kind of graphing template, our formula, that means that typically it starts here, right? So if our midline is at positive 2, I'll just kind of draw it out here. If our midline is at positive 2, to go from the midline to the maximum, we have to move up 4 units. And to go from the midline to the minimum, we have to go down 4 units. Okay, so the amplitude, the absolute value of kind of the magnitude of this thing is going to be 4. So a is going to be 4. Okay, and the last thing we're trying to find is the b value. Well, that shouldn't be too hard using our formula we used before. So the period of this is just the distance from the trough, the distance from, the peak to the other peak. So this coordinate here is negative 1, which we just found. And this peak here is going to be, what is that? That's going to be 2.14. Okay, so this looks like the period is still about, let's see, if this is -1, this looks about 4, this would be 5, this would be maybe like 5.3, something like that. So the distance between these would be 6.3. And notice that 6.3 is awfully close to 2 pi. So 2 pi is approximately 6.28. So if you had a graph where it listed the x values as integers and not in terms of pi, you're going to have to use a bit of thinking. Typically, they'll be in terms of pi, so it'll be easier. But right now, you can kind of see that the distance between these is about 2 pi. So it's probably safe to say that the period is 2 pi. So if the period's 2 pi, the b value is just 1, right? Because b is 2 pi over the period. And if our period's 2 pi, it's just 2 pi over 2 pi, which is 1. So we don't need to worry about the b value right now. We can just leave it. Right? We can write b equals 1. That doesn't do a whole lot. So find an equation. We're using positive cosine. So y equals cosine. Our b is 1. X minus -1 plus 2, right? Okay, cosine x minus -1 is just x plus 1. And then we got plus 2 here. And we could verify this by plugging in coordinates like we did last time, but it's gonna be correct here. And I don't know why I didn't put 4 in front, because remember our amplitude was 4, so y equals 4 cos theta. There we go. Perfect. So we just kind of went over some transformation ideas, the basic formulas, how to convert sine and cosine, right? It's just that phase shift. That's the only difference. What our a, b, c, and d values were. Hopefully this made sense, and I'll see you in my next video to talk more about transformations, graphing sine and cosine functions.